All right, so few things to know, and you probably have been told this, but we have 3 full weeks and 2 days, and then we get to go on Thanksgiving break. Once we get back from Thanksgiving, we have 2 weeks, and then the following week after that is finals, and then winter break or Christmas break. Now, there is an very important date in there in December that you all need to put on your calendars, and I believe it's December 16th. That's when Rogue One from Star Wars comes out. We need 2 more. Jeez. So December 16th, Rogue One from Star Wars comes out, so that's an important date for y'all. At least it might be for me. I guess. Actually, give it to Zach. So my point on telling you all that is, I mean, we have covered a significant amount of the semester. Hang on. Woo! But I hope y'all had a nice break. That's a good break. So cheap. All right. Let's do some notes. All right. Classifying triangles. Goal: extend previous understanding for classifying triangles and find missing measures. Okay? So triangles, you have measures, you have angle measures that are the angles. They all sum up to 180 degrees, but we'll get over that. And then there's ways of classifying triangles either by angles or by sides or even both. So that's some things just to kind of know that we are heading towards. We still good? Everyone have one of these? Oh, I forgot to put the 3-hole punch in there. I'm sorry. All right. Classification of triangles. So a scalene triangle, isosceles, equilateral. Let's see if these have none. So no congruent sides is scalene. At least 2 congruent sides. And equilateral, all 3 sides are congruent for an equilateral. And then acute, let's see, I have this to move out of the way. Acute has 3 acute angles. An acute angle, if you don't know, is an angle that's smaller than 90 degrees, but also bigger than 0 degrees. A right angle has a 90-degree angle in it. You can only have one right angle in a right triangle if it's done in Euclidean space, which means you can write it on a flat space. And then an obtuse, one obtuse angle. That means you have an angle that happens to be larger than 90 degrees. So you can classify a triangle as scalene, isosceles, or equilateral. If you're talking about just the sides, you can classify it as just by the angles, or you can classify it by both the angle and the side. So you could have a scalene acute triangle. It means all 3 of the angles are not the same, and all 3 of the sides would be the same. So what's the right way, scalene acute or acute scalene? I think it's preference. How are you raised? I don't know. Sound good? Everyone have heard? Has everybody heard of these types of triangles before? So name it by sides, name it by angles, or name it by both. So my daughter's soccer team that I coach, my daughter earned her first yellow card. It was our first yellow card in 8 years of this team being together. She got the very first yellow card. You want to know what she did? Gosh, I wish it was that bad. Nope. Okay, side ref, the guy with the flag, calls goal kick. So my daughter says, sweet, we got a goal kick. Just like that. The center says, it's a corner kick. Cards her. Jeez. So I'm like, as a coach, going, what do we got? And he goes, yellow card for dissent. How is that? I'm walking on the field. What's going on? So he comes over, okay, coach. She argued with me. Exactly how did she argue with you? She said, sweet, we have a goal kick. Was there more? No. How'd she say it? Just like that. Who'd she say it to? The goalie. How is that dissent? Well, she was arguing with me. Was there more to this conversation that I didn't hear that you just said to me? No, she said, sweet, we have a goal kick. Who'd she say that to? The goalie. My goalie? Yes. To you? No. What part of dissent do you not understand? Coach, you're real close to getting kicked out of here. I said, no. Now this comes from a father. Say, you can't do that to a 12-year-old kid that doesn't deserve it. Coach, you're out of here. So I got ejected from the game.
You should have just
Yeah,
played
we won.
baseball.
So
Why you don't swing at it?
So then I had to sit out. I had to sit out one game because I was ejected, which is an automatic red card. So I told the State Soccer Association, happy to sit out. Is there a website that I could fill out to file a complaint against this referee? Well, what's your complaint? Explain my whole thing. They're like, yeah, here's the website. So, okay. I said, other things that happened during the game. The one side ref was looking at the houses behind him, not even turned to the field. The ref on the opposite side sat on the trash can for 20 minutes during the second half of the game. Not leaned against the trash can, didn't stay with the play, like hopped up, legs dangling. He was like a 65-year-old guy. What part of that is reffing? Why are you paying these people to do this? So, yeah, that was my break. So, my daughter earned a yellow card, and yours truly got the red card out of here. But, hey.
How did you swing?
A red card is worth
Oh, I won't swing on him.
A red card is worth it if you like breaks my.
Oh, I wish I could have made the red card worth it. Nah. You know, it hurts too much to hit somebody anymore.
No, you hit him with the palm.
No, it hurts too much.
But that's like chin
I know. The last thing I need to do is go hang out and, look through the vertical bars. What do you do? I'm not going to do this. All right. What do you think is meant by equal angular triangle?
Triangle with equal angles.
Triangle equal angles. So if it's equal angular, that means each of the angles has to be 60 degrees. Okay? The only way that's going to happen is all three angles of a triangle have to add up to 180. If it's equal angular, all three angles have to be equal. In order to have all three angles, that would be 3x or 3 delta or 3 unknown equals 180 divided by 3, and you get your unknown or your angle being 60. What is the definition of an acute triangle? Acute triangle, 3 acute angles, while the other definition only mentioned one particular angle. Why is the definition of an acute triangle 3 acute angles, while the other definitions only mention one particular angle? So if all 3 angles, go ahead.
Because in order for the other angles to be a triangle, they have to have 2 acute. So for it to be an acute, it has to have 3, but the others automatically always have 2.
Right, there you go. So if you have an acute triangle where you have 3 acute angles, that's 3 of the angles, all are less than 90 degrees. If you have a right triangle, the other 2 angles have to sum up to be 90 degrees, which means they both have to be acute in that case. If you have an obtuse angle, meaning the angle is larger than 90 but less than 180, the other 2 angles also have to be acute to add up to it. So there's just a few things to think about with how those triangles work. Can I move on this? Anything down here? Nope. All right. Informal proof that a triangle's angles must add up to 180. Okay. Let's see if we can do this. So this angle here, ready? See, it goes right there. And this angle goes here. See? Does that work? And this angle goes here. Still with me? So if I were to take these 3 angles, let's see, how can I do this? Can I rotate? Nope. Green. Whoop. Okay. this. A little bit more. This one. Notice the three angles, when you put them all together, you move them around, they create what? Supplementary. It's a straight line.
Nice.
Okay, so any three angles, any triangle, if I cut off each of the angle and I put the three together, they would add up to 180 degrees, which is not on purpose. Come on, get out of there. Move. Okay. Anybody? Okay. There we go. Just setting this up for next period so it looks special for them too. Sometimes they get left out. Cool. So I could have done a cutesy thing, given everybody triangles, say, okay, rip each of the three angles off to see if you can put it together. But I'm not that cutesy. I'm sorry. I wish I was. Okay, so that's basically the thing. So it doesn't matter which triangle you have. It doesn't matter if it's a right triangle. It doesn't matter if it's a obtuse triangle. It doesn't matter if it's acute. The three angles always will add up to 180 degrees no matter what. And again, I'm sorry, I'm not cutesy. Formal proof. Start with the generic triangle ABC. Start with the generic triangle ABC. All right. A, B, C. Seem good? Add line DE parallel to the base of the triangle. Well, which one is the base? It appears to be AB in this case. The base is usually the one that's the horizontal line across your paper. But honestly, any of those could have been the base. We just have to identify. So start with a generic triangle ABC. Add a line DE parallel to the base of the triangle. Seem okay? Close enough to have an AB and DE being parallel to each other? And I guess I should put an arrow at each end because they wanted a line, so it's going infinitely. What angles must be congruent? Maybe we should move this to this. Line lit up too? Yeah, baby. Okay, if AB is parallel to DE, I would say you could probably go through. You could know that this angle and this angle, those are called what kind of angles? Corresponding. And this angle here and this angle here, because of corresponding, we could go, I don't know. We could go, let's see. If I extended that line and that line, we have these, because those are alternate interior, correct? Obviously, the vertical angles take place. If I extended this line through and this line through, I could go ahead and say that that red and this are congruent because alternate exterior. Okay, there's a number of other things I can obviously show that I have a whole bunch of vertical angles, but there's a lot that you could show with this triangle having congruent angles. You know, corresponding definitely works. Alternate interior, as long as we extended all of the line segments. Alternate exterior, same side interior. I'm sure we don't have them. Same side interior could be like this angle here and this angle here have to add up to 180. Okay, which would mean that triple and this quadruple would have to add up to 180. Okay, so those are same side interior. So there's a lot that we could do with this just with our mechanics of geometry. We good? We proved our first theorem in chapter 4. Yay. The blank of the interior angles of a triangle is blank. Let's see. Okay, where's that? What? Where are my words? Where's my boxes? That shouldn't be my box. Where are they at? The what? The blank of the interior angles of a triangle is the sum of the angles of the interior, or the sum of the measures. Okay, go with that. Sum of the measures of the interior angles of a triangle is 180 or supplementary or something like that. That'd work. Sum of the measures of the interior angles of a triangle is supplementary. Is 180. Anything like that. Am we on the back side now? And while we're at it, we're talking about degrees. So there's two different major measurements that we use as far as angles go in math. One is degrees, and usually, it goes from 0 to 360 as far as circles go. It can definitely go further than that. Snowboarding, skateboarding has made us become aware pretty easily of, dude, 540 is 1.5, 720 is twice around, 1080 is 3 times around, 900 is 2.5 times around. So skateboarding has really helped me out in my understanding of math. I don't know about y'all, but that's where I gained my knowledge. There is something also called a radian measure, which we will get to later. And a radian measure is basically the same thing. It's like using Fahrenheit versus Celsius versus Kelvin. Those measure temperature in your science classes. And then we also could do angles by degrees or by radians. So it's just a matter of how you look upon it. As you get to calculus, radians are used more and more often. And don't let it confuse you, because it's pretty easy to go back and forth between radians and degrees if you needed to. All right, for triangle ABC, angle 1, angle 2, and angle 3 are supplementary. Cool. I'm just going to put sup. Angle 4 is considered an exterior angle, okay, of the triangle with relation to angle 4. Angle 1 and angle 2 are blank angles. Acute angles. They're acute angles. Now, I don't know if this is next screen. Let me see where you're at.
Wait, couldn't you have
Angle 1 and angle 2 are underneath there. I'm just going to say this. That angle 1 plus angle 2 has to equal angle 4. Let's make that work real quick. Angle 1 plus angle 2 equals angle 4. So the exterior angle off of angle 3, if I were to take this angle and add them together, the sum of those two angles would equal angle 4. Now think about why this would work. If I had taken angle 3 and I cut off angle 1 and put it here, and put angle 2, it's going to follow that straight line. Wow. So, yeah, that's the thing. And you also, things that you would also know is that angle 3 plus angle 4 have to equal 180 degrees, because they're a linear pair. I don't have a thing to draw off of it. I'm sorry. I'll find it next period, I bet you. All right. So we now know that the sum of measure angle 1 plus 2 plus 3. What about measure angle 3 and 4? 3 and 4 we just said has to equal 180 degrees. So angle 1 plus angle 2 plus angle 3 has to equal 180. Agree? And then we know that angle 3 plus angle 4 has to also equal 180 because of linear pair. So then, using the transitive property, we can say that angle 1 plus angle 2 plus angle 3 is equal to angle 3 plus angle 4 because of the transitive property. And I can subtract angle 3 from both sides, and again, we've just proven why this works. Nice little proof. That's not really done nicely, it's just algebraically showing it. Can I move on? We have now proven theorem 4.2. The blank of an angle of a triangle is equal to the blank of the blank angles. Thoughts? I don't know where my words are. Oh, there they are. There we go.
What?
Oh, yeah. All right. We have now proven theorem that. Okay, so what does that get out of there? The measure of there and there. Any more? Ooh, maybe here. That's it. The measure of the exterior angle of a triangle is equal to the sum of the two remote interior angles. So two remote meaning the angles that aren't attached to the third angle of a triangle. Again, we just did that proof. May I move on? All right, find the measure of each angle. Angle 1 is how much? And why? How big is that angle? 65 plus 90, which is? 155? Good? All right, let's see. This plus that has to equal this, so 80 plus 18 is 98 degrees is angle 1. And then we could easily find that angle then too, correct? Because the three angles have to add up to 180, or this and this has to equal 180. What about this one? Oh, there's an obtuse angle here, 41 and 32. So angle 1 has to be 41 plus 32, which is 73 degrees.
Oh, 73.
Yeah!
How do you find like the other angle actually in
This one?
yeah.
So either this plus this has to equal 180, or this plus this has to equal 180. So you just easily be able to find it. So that would be what? 25? Is that right? No. Yeah, 25. 25 there. This one would be 107. And that last one is 82. Yeah. Sweet. Find, measure, DEF. So DEF is here. Algebraically, how are we going to find it?
3x plus 6 equals 80 plus x.
3x plus 6 is equal to 80 plus x. Good. Using algebra, subtract x, I get 2x. Subtract 6, I get 74. Divide each side by 2. 37 degrees. So this angle here is 37 degrees. What is this angle then?
127. No, 130.
3 times 37 plus 6? Help me out.
Just add 8 to 37. 121.
120, what?
I'm trying to. It's 117. I'm trying to think here.
117?
So hard.
Sweet.
Times 30 equals 90.
Sweet. All right. Uh-oh. Find x and y. So we were trying to figure out these two angles here. Oh boy, oh boy, oh boy. All right.
Oh, 35 plus 18 is 450.
So let me do this. Let me do this. Can I go highlighter? Can I do this? Let me find the missing angle here. How do I find that missing angle?
Well, that's right.
180 minus 125.
Oh, 90 plus 35.
So it's 55.
55? Agree? Anyone stuck on that? Because that's 90, right? So 90 plus 35 plus 55 is 180. How big is this angle then? 55. How big is that one got to be then?
35.
35 degrees? Okay. Then, how big is this angle and why?
It's 125.
Why is it 125?
180 minus.
This is supplementary. This plus this has to be, so 125 you say?
Yeah.
And so 125 plus 18 is how much?
143.
Minus 180 minus 143?
37.
37 degrees? Sweet. Oh, that's awesome. Other things we know that this has to be 125 degrees because of vertical angles. You want to do that. That's about all the angles you can find. So utilize it. I mean, don't allow some of the, they're going to put shapes on top of shapes. So use the knowledge you know. 180 is a big number to go with. The vertical angles are going to be big. That clear as mud? Cool. Questions? All right, classify this triangle by its angles.
It's an acute triangle. Ooh, it's acute.
What is it? You're calling it acute.
Oh, I'll look at the front of it.
Oh, it's nope, I'm not doing it.
I saw some.
Well, if you add them all up, you're going to get what? 4x, and that's equal to 180. Divide each side by 4, so you'd get 45. So that's 45, and that's 45, and that's 90.
Gaily.
So classify the triangle by its angles.
Angle side theorem has the sides congruent to each other.
What's one angle that is of an important angle?
The 90. It's a right.
And the 90, it's a right. So this is a right triangle.
Let's get it.
In this case, it is a right isosceles triangle, and we'll get to a point where we realize that side and that side are the exact same, but we're not quite there yet.
Wait, so I know for this one, it says right triangle.
No, scaling would mean all three sides are equal, and this one would have two sides equal. Oh, wait, where did that one go? Was that on the worksheet? Oh, yeah. So, 369 is a right triangle. That's all you can label it. You could label it as scaling as well as all three sides are equal. All right. It is time. Let's do it.
Yes!
Does anyone need a Chromebook? Anyone need a Chromebook?
I turned my phone off.
Anyone need a Chromebook?
Yeah, we do.
Is it open? No one's joined yet. What's up with that?
I got you. Hold up. I need her. The Wi-Fi is like
the Halloween thing.
Wi-Fi's boosted. Got 4 in the house. 5,
What's the game? Oh.
What's it called?
6.
One click on your name, you're out of the game.
9 people. 30 more seconds.
What's the game?
144307.
1 second.
27 seconds. 20 seconds.
Oh, it's like Halloween themed.
1, 4, 4.
Here we go. I'm gonna.
10 seconds.
Harambe is dead.
So he was just a
Stop it.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Oh! Duplicate of geometry, chapter 4, chapter 3.
17 questions. You ready? Classify the triangle. Uh-oh. Uh-oh.
I just take a guess.
Oh,
That's so good.
Anyone else?
time doesn't matter.
Oh. Oh.
Who is this movie?
Huh?
Coming after you.
I don't know most of those people. I don't know.
Three ones. Here we go. Jillian, 925.
Classify a triangle.
Classify the triangle. Here we go.
Oh, I just.
What the heck?
Oh, yeah. 3 people guessed equal angular.
Oh, yes! Third place, baby!
Watch this. Look.
Third place.
Oh, Jillian's still up there.
You see?
All right, should we go? Classify the triangle. Oh, yeah.
Yes!
It's not cute. Oh my god.
It's equal angles.
Oh, some of you, 4 of you thought it cute. Which technically you're kind of right, but they're the same size.
Second place, let's go!
Oh, yeah.
Get there, go two!
Classified in the triangle still
That
coming.
has space.
Uh-oh. Ooh.
Oh my gosh.
Who's the like? Yeah, it's a cute ad. Oh, congratulations, class.
Second place, let's go!
Woo. Classify the triangle.
Yo, let's go!
How do you know that?
That's so funny.
Second place, let's go! Who is this Jillian?
She's whooping you. Ooh. Obtuse. Oh, that
First
big
place, let's go!
Oh.
Let's go! Get out of here, Jillian!
Oh, Jillian, what happened? Oh, no. Classify the triangle. Ooh. Sides A, A, and A.
Go! First place!
Uh-oh.
Let's go! Yes!
Oh, Casey's catching.
Casey.
Casey, extra credit if you catch him. And pass him. Sure, I can say.
I'm not paying attention. I'm not paying.
I don't know that. Oh, shit.
So you're naming it by the sides, right? Not the angle. named it by the sides, not the angles. You did? Oh yeah! What happened? Where you at?
I don't know. I boosted.
Classifying the triangle. Remember, you can name it by the sides or the angles.
Oh shoot. Oh my! Quit.
I said scaling.
Uh-oh.
Fourth place, let's go.
Classifying. It might change to angles and sides that you have to do both.
Oh, I can't see.
You see that? Oh yeah, scaling. Oh yeah.
Let's go.
Classify the
This is
triangle.
the comeback season.
Yeah, baby.
Oh.
Who's lagging? Equilateral. Oh, look at that. Of the 18 of you that played. Yes. Yes.
Boy, it's not loading.
Classify the triangle.
Oh shoot. Jeez. Three.
Blue square.
Seven. Go, 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 go. Gerald, I'm coming.
Classify. Where go?
Sawyer.
Oh yeah.
Oh wait, I missed Clay. I missed Clay. I'm cheese. Green. I'm so cheese.
Oh, it's the green one. It wasn't a right angle sign, so.
Oh, you're 20th now.
Uh-huh.
Woo! First place.
Lynn, okay, Lynn, you're gonna get a rush.
Classify. You have to use both now.
Oh shoot! I saw Clay. Ah shoot! Blue.
Oh yeah. Ooh.
Gerald.
3 more questions. 15, 16, 17. That's it. Oh yeah.
Let's play another one.
Acute scaling. Who's got the lead? Still there by 700 some odd points.
I'm done.
Emma, you gonna catch it?
Jeez. Oh no.
Blue triangle.
I'm so cheap. Yellow. It's green. Yellow. Blue.
Equiangular and equilateral. That was what you asked before. Uh-oh. Oh, look at that. Last question. Will we have a lead change?
Yes.
Oh,
Yes.
Blue.
Red.
Green. Purple. Yellow. Purple. Clear. It's white.
Who's lagging?
It's white. It's white.
Right scaling, huh? Oh, and the winner is. Ooh! All right.
You got everyone.
Oh my god.
All right. So you guys know what your assignment is, yes?
No.
Homework worksheet 4.1.
Oh no.
So we will quiz over sections 4.1 to 4.3 on Friday, November 4th. That's this coming Friday. Oh, you guys rock. Hey, wait, let's not let it by the door yet because we still got a little time.